Okay, 73rd I'll solve. Any other question?
Yeah, that 72 as well.
72. Okay. Okay, let us start with 72. This pen. Sorry. Okay, so I'm doing the 72nd one. Okay, 72.
Alright.
So you have sec A minus tan A is equal to x. Okay. So you have to prove this, that x square plus 1 and divided by x square minus 1. Okay, so let us put the value of x here. So you have sec A minus tan A whole square and then plus 1 divided by sec A minus tan A whole square minus 1. Okay, so let us first open the bracket. A square plus minus A minus B whole square. So it will be sec square A plus tan square A minus 2 sec A tan A plus 1. Now divided by again sec square A plus tan square A minus 2 sec A tan A minus 1. So you need cosec. That means 1 upon sine. If I convert everything first of all into sine and cos, I think it will be simpler after that. Okay.
Yeah, ma'am. Sure.
Yeah, so sec is 1 upon cos square A plus sine square A divided by cos square A minus 2 into 1 upon cos A, and this is sine A divided by cos A, and then you have plus 1. Now again divided by 1 upon cos square A plus sine square A divided by cos square A minus 2 into 1 upon cos A into sine A divided by cos A minus 1. Okay, so see, the denominator is everywhere cos square A. Can you see that?
Yeah.
So if I take the denominator, LCM cos square A, so this is 1 plus sine square A minus 2 sine A, and this plus 1, now this will be multiplied because there was 1 in the denominator. Okay. And similarly here, so again, this is, if you take the LCM cos square A, so it will be 1 plus sine square A minus 2 sine A and then minus cos square A, right? Okay. Now in the new here that you can see this sine square A plus cos square A is 1. Okay. Then another 1 is also here. So 1 plus 1 is 2. Can I directly write it? And see, this cos square A, this cos square A will cancel out. So here again, okay, so I cannot use the identity here. So what I can do is, if I just combine this 1 minus cos square A together, and then you have plus sine square A minus 2 sine A, right?
Yeah.
Now, okay, so now if I take 2 common, it is 1 minus of sine A. Now in the denominator, 1 minus cos square A is sine square A. Then you have another sine square A. So, okay, let us first write plus, then you have sine square A minus 2 sine A. And whatever identity you are using, Martin, you have to mention it here, all right?
Yeah, ma'am. Sure.
Okay. So this is 2 into 1 minus of sine A divided by, so this is now 2 sine square A, right? And minus 2 sine A. Now I can take 2 sine A common, right? So I get sine of A and minus 1. Okay, so to make it same, I can take a minus common. So from the numerator, if I take a minus common, it becomes sine A minus 1, right? Sine term will be plus and 1 will become
Yes.
minus. Okay, now divided by 2 sine A into sine A minus 1. Now the complete bracket will cancel out. And this 2 will also cancel out. So it will be just minus 1 upon sine A, and which is minus of cosec A. Yeah, Martin. Done?
Um,
Okay. Hamna, are you here? Yes, Hamna, can you hear me? Hamna, please unmute yourself. Yeah, what about the homework I gave you? Today I'm going to call your parents. Martin, yours also, and Amna, yours also. You people are not submitting me any work I'm giving you.
yeah, I'm done.
Okay. Now 73rd question you said you're not able to do. Let us solve it. So if I write the LHS, so this is cosec A minus of cot A divided by cosec A plus cot A plus cosec A plus cot A divided by cosec A minus of cot A. So Martin, tell me one thing. So are you going school these days?
Yeah, now, like report one just finished.
Okay, so what's going on in the school right now in mathematics? What they're doing?
Now I'm doing revision. I mean, like next week is the revision class is gonna start. Like
Next.
report
Okay.
just.
Okay. So are they also giving you some assignments or questions or something to practice right now?
Yeah, I think so. Like revision worksheets and all.
Okay. So you can also share your worksheets with me. If you're not able to do any question, we can solve it together. Okay. And how many hours you are devoting for your practice every day?
1 hour, 2 hour.
1 hour, 2 hour. Okay. See, Martin, please do proper revision of every chapter. Please do homeworks. See, currently I'm only focusing on previous year's question and a lot of questions repeats in boards. Okay. I mean, you will be habitual of solving questions. So please do every day, right? All your homework.
Okay, ma'am.
See, this question is not tough. Just convert everything into sine and cos and try to solve it. It's very easy. You start doing it. First, convert it into sine and cos, then I'll help you.
Convert to sine and cos.
Yeah, so write cosec A as 1 by sine A. Cot A will be cos A by sine A. Yeah, Hamna, can you hear me now? Yes, Hamna, can you hear me now? All right.
Yeah, ma'am, I converted it.
Hamna, please unmute yourself.
Yes, ma'am.
Okay. What about the homework, Hamna, which I gave?
Yes, ma'am, I did some questions.
Okay. Any
Ma'am, I did
question?
not understand the seventh one.
Which one?
Seventh one.
Seventh. There were some question numbers, right? 69, something like that. Oh, okay, okay. You're talking about the assignment. Right, right. Okay, I'll solve it. Wait. Yeah, Martin, right? So you can separately take LCM now. So first,
Um,
this is sine A. So you get 1 minus cos A. And similarly, the LCM will be sine A. It will be 1 plus cos A. All right. And now the LCM will cancel out. So it will become simpler. Similarly, this side. Now please complete it. So basically you are left with 1 minus cos A upon 1 plus cos A. Now here sine is sine A, so you will be get 1 plus cos A, and in the denominator you will get 1 minus cos A. All right.
yeah, ma'am.
Okay. So now again you can take LCM because there are two terms. So LCM will be 1 plus cos A into 1 minus cos A. All right.
Yeah, ma'am.
Okay. So this time 1 plus cos A is already here. So it will become 1 minus cos A whole square plus. Now it will become 1 plus cos A whole square. Is that clear? So
Sure, yeah, ma'am. Yeah.
1 minus cos A is nothing. There's no identity. So you can open the bracket A minus B whole square. So A square plus B square minus 2AB. Similarly here, A square plus B square plus 2AB, right? And in the denominator, you have A plus B into A minus B. So that is A square minus B square. So 1 minus cos square A, right? Okay. Now this will cancel plus and minus, right?
Yeah, ma'am.
Okay. Now I have, so 1 plus 1, I have 2. Then you have, yeah, okay, both are cos. So you get 2 cos square A. That's it. And 1 minus cos square A is sine square A. So what you have to prove, what is the RHS? Okay. No. RHS is in terms of cos. So don't change this in sign. Keep it like this, cos square A. You can just take 2 common. So it will be 1 plus cos square A and divided by 1 minus cos square A. Hamna, were you able to solve this one?
Yes, ma'am.
Okay. So what I want, yeah, this is the RHS, right, Martin? Yeah, okay, fine. So it was not that tough, I think. All right, so Hamna, you are saying 7th question of the assignment. Let's just open. Okay. Yeah, Martin, done.
Yes, ma'am.
Okay, now come to your assignment. So this is 7th question I'm solving. Okay, M is equal to cos A minus of sine A, and you have N is equal to cos A plus sine A, and then you have to, basically you have to find this value M upon N minus N upon M, right?
Yeah, ma'am.
Okay. So you have to show this minus 4 sine A cos A divided by cos square A minus of sine square A, and also one more step you have to show that this is also equal to cot A minus of tan A. Yeah. So from here to here, I think, okay, anyway, let us do it. Then we will see. So let's put the values of M and N first of all. So I am doing this M upon N minus N upon M. So my M is cos A minus of sine A divided by N is cos A plus sine A minus N cos A plus sine A divided by M is cos A minus of sine A, right? So you can take LCM, Hamna, right? LCM is cos A plus sine A into cos A minus of sine A. You can directly see this will become A square minus B square, which you have to show here in the denominator. All right.
Yeah, ma'am.
Yeah, okay. Now, so plus is already here. So here I get cos A minus of sine A whole square, then minus, sorry, this is cos A plus sine A whole square. Now open the bracket. A minus B whole square and A plus B whole square. So A square plus B square minus 2AB. 2 cos A into sine A. Minus, now please use a bracket because you have a minus outside. A plus B whole square. So cos square A plus sine square A plus 2 cos A sine A. And then divided by, okay, you please continue. My screen is a bit hanged. So in the denominator, you get cos square A minus sine square A, right? Fine, Hamna?
Yes, ma'am.
Okay. So now if you open this bracket in the numerator, all the plus terms will become minus, right? So can I directly cancel out? So one is plus, one is minus, right? Then again, this is plus, this one is minus. And this one will also become minus when you will open the bracket, I mean this term. So minus and again minus. So 2 cos sine A and 2 cos sine A. It will become 4 cos sine, 4 cos A sine A. Is that okay? But with a minus sign, both are minus. Any problem here?
No.
I mean, you can write an additional step. First, open the bracket. Otherwise, I have done it directly. So the first step you have already done. So this part we have shown. Now we have to show this part. Okay. Sorry. See, Hamna, listen here. Whenever you are stuck with something like this, okay? So there's no identity with cos square A minus sine square A. But if you divide the whole term, for example, by cos square A, so you can, no, not with cos square A. If I divide both numerator and denominator by cos A sine A, because in the numerator I only want minus 4. Can you see that in the question?
Yeah, ma'am.
Okay, so let us divide both numerator and denominator by this. Divide numerator and denominator by cos A sine A. So I'll get minus 4 cos A sine A divided by cos A sine A. And then I have this cos square A minus of sine square A. This is also divided by cos A sine A. So here I get, this is just minus 4. And then I can split this LCM in the denominator. Yeah, just a minute. Are you able to see my screen?
No, I can't.
Okay, just 1 minute. Okay, let me write here. So in the numerator, basically I was left with only -4. And then I was having cos square A minus sin square A, right? So I'm just splitting it. So cos square A divided by cos A sin A minus sin square A also divided by cos A sin A. So I get -4 divided by, so cos is cancelled. So this is just cos A by sin A now. And this one will become sin A by cos A, right? So it will be -4
Yeah.
divided by cos A by sin A is cot A minus this is tan A. Yeah, so this is the second part of the question.
Oh, okay. Can you go to like the previous slide? Copy that.
Yeah, my one, yeah, okay, now it is working. Just a minute, sorry, my OneNote was actually not responding.
Mm.
Hamna, any other question from the assignment?
Yes, ma'am. The 11th one.
11th, okay. Yeah, sorry, Martin, my screen is a bit hanged. Just wait for a few minutes. I'll share it again.
Okay.
Okay, I lost my connection. Just a minute. Yeah, Martin, am I audible?
Yes.
So you can complete the question, Martin. This was easy, right? Just take LCM and then open the bracket and solve it. Yeah, have you done, Martin?
I think it's homework.
Hmm. Okay, just a minute, Hamna, I'm solving it. Yeah, so this was the question mark, Martin. I just took LCM here. Then I opened the bracket, a minus b whole square and a plus b whole square. And I have added the terms together. Okay, done, Martin? Sorry. Okay, let us solve now the 11th question of the assignment. So you have tan theta plus sine theta is equal to m, right? And tan theta minus sine theta is equal to, okay, sorry, one has to be n here, Hamna, okay?
Yes, ma'am.
Both have been written m. Then you have to prove this thing that m square minus n square is equal to 4 under root m into n. So first let us put the values here. So if I solve this m square minus of n square, let us see what we get here. So I put this tan theta plus sine theta whole square minus tan theta minus of sine theta whole square. So a plus b whole square and a minus b whole square, let us solve it. So a square plus b square plus 2ab. Again, you have a minus sign outside, so be careful. So a square, that means tan square theta plus b square and minus 2ab, so it will be plus this time. So 2 tan theta sine theta. You can put a bracket in the first step and then you can open the bracket in the second step. I have done it directly. Fine, Martin? Otherwise, you will make a sign mistake. Definitely you will make, okay? Be careful here. Okay. Now, so some terms will cancel out. Tan square theta, tan square theta. Then this sine square will also cancel. Now you have 4 tan theta and sine theta. Okay. So I think here, now we can also solve the RHS and we can show that both are equal to this thing. Because you are simply have tan theta sine theta, you cannot do anything much here. So if I also solve this thing, let us solve this thing under root mn. Let's see what we get here. Or let us first find out simply what is m multiplied by n. All right, Hamna, then we can take square root. Otherwise, in every step, you have to put a square root. Is that okay?
Yes, ma'am.
Okay, so m was this tan theta plus of sine theta, and n is this tan theta minus of sine theta. Okay. So it will become a plus b into a minus b. So we can use an identity. I think it will become tan square theta minus of sine square theta. Fine, Martin. A square minus b square.
Sure.
Okay, now let us convert this into sine and cos. We can write it as sine square theta divided by cos square theta minus sine square theta. So let's take LCM now. This is sine square theta minus of sine square theta into cos square theta. Yeah, okay, see what is coming. I can take sine square theta outside, right? So I get 1 minus cos square theta, which is again sine square theta. No, sorry, you have cos square theta. Oh, no, sorry. In the denominator, you have cos. Yeah, no issues. Sorry. So you have here sine square theta. 1 minus cos square theta is again sine square theta. All right. And then you have cos square theta. So can I just, I can again write tan square theta into sine square theta. No problem. Yeah.
Yeah.
So basically my m into n is coming out this thing, tan square theta into sine square theta. Now you can take under root. So it will make, you can now simply write tan theta sine theta. So basically I wanted to avoid putting every like square root in the every term. So I'm taking it afterwards. Okay, Hamna.
Yes, ma'am.
So basically what I'm getting here is this thing. Yeah, now this is done. See, what I'm getting is my results are this. The first result when I was finding this m square minus n square. So I got this 4 tan theta sine theta, right? Now what is this 4 tan theta sine theta? If I just put this equation number 1, in place of this, I can write under root mn. Isn't it? From 1. This is proved. Yeah, any other question? Martin, is that okay?
Yeah, ma'am. Can I write this?
Yeah, sure. See, just don't get confused, Hamna. Just look here. You have solved LHS first of all. So you got this m square minus n square. The answer was 4 tan theta into sine theta. All right. Now you can solve your RHS also. Just do it directly. If you want to find this value, just put everything here and solve. You will get the same thing. Okay. And if you want to avoid the square root in every term, so you can separately find the value of m into n first of all. Then you can find this. Is that okay? You will again get this. So anyway, you can proceed. Yes, Martin, you can write it down.
Okay.
Yeah, Hamna, any other question? Yeah, what about the 15th question, Hamna? Have you done it?
Can scroll down.
Yeah, Martin. 14th, 15th are easy that you can do. They are basically trigonometric ratios. Hamna, have you done the 13th question? 12th and 13th question?
Yeah, can scroll down.
Hamna, just tell me one thing. In the chapter of statistics, so have you also done that less than and more than ogive in the school?
No, ma'am.
No. Okay. Yeah, because it's not written in the syllabus this time. So I also did not do it. Let's have a test on Tuesday.
Which chapter?
Okay, so the last test which I took was of the chapter real numbers and polynomials. Hamna, you did not attempt that test. Why?
Ma'am, I had an exam.
Okay. Now your homework is, Hamna, now your homework especially, you will solve the test paper and you will send me as a homework. Okay. I've already sent you on the WhatsApp the PDF of that test.
Now please scroll up.
Okay, fine, Martin, you complete your question. Fine.
Yeah, ma'am.
So Hamna, the test paper for real numbers and polynomials you will solve. Let's have a test of linear equation in two variable and quadratic equations this time. Yeah, it's done, Martin.
Hmm. Yeah, ma'am, done.
Okay, now few more questions I'm giving you because we still have time. Okay, please start solving them and ask me if you have problem.
Okay, ma'am. And first round we convert that to sine and cos it.
Sorry, I was on mute.
Okay. So
So were you able to catch up? I didn't notice. I was on mute.
yeah, ma'am. Okay. So,
So here I'm using this identity. Okay, a cube minus b cube. So the
oh,
numerator is now a cube minus b cube. 1 can be written as 1 cube, no issues. So this will be a minus b. That means tan a minus 1 into a square plus ab. That means only tan a, and plus b square. That means 1. And then again divided by tan a into tan a minus 1. Now this tan a minus 1, this bracket will